In the previous lesson, I wanted to talk about helper methods, and to make the application more interesting, I employed the use of the random class. And the job of the random class is to generate random numbers. In this case, we're using random numbers to determine the amount of damage that one character does on the other character. And as some users noticed, the numbers that were produced were oddly similar, and to kind of accentuate this, I added a result label to display the actual damage that is being generated when calling next each time. And so you can see here that every time the roll is 3. These are not random numbers at all. However, and this was, I think, odd whenever some users actually came to this realization, they set breakpoints to see what was going on. That's a great idea. So when they ran the application with a breakpoint and we hit the breakpoint and they investigated the value of damage and then take a few seconds and step over some lines of code and then hit the continue button again and then step over some lines of code, whoop, damage has changed this time. It is more random. Here, let me pin this little guy down. Okay, so we can watch it. And so I've waited a few seconds. I'll hit continue again. This time damage is only 2. And we'll just continue on. And in fact, I'll just go ahead and get rid of the breakpoint at this point and continue running. And so you can see that now, whenever we used a breakpoint and took our time and stepped through the code, that we do get numbers that seem to be random until we stopped and we removed the breakpoint and then we let the application continue running, at which point we continue to get the same roll of 4 throughout the rest of the run of the application. So what is going on here? Well, the reason this happens is because the random class does not actually generate random numbers. It approximates random numbers given a seed value, and a seed value is like a starting point, a starting number. And if you were to give the application or give the random class a different number, then you will get, in theory, a different value each time. Now, in this case, when we create a new instance of the random class, and I realize that I'm going to use terminology here that that we've not talked about yet, and I'm going to talk about it soon, just haven't quite gotten there yet in this series. So some of this will be covered later on. So just kind of ignore any of this and just follow along the general idea that I'm trying to explain here. If you take a look at whenever we create a new instance of the random class, the class's constructor will be called. And this particular constructor has 2 overloaded versions. There's 1 of 2 and 2 of 2. And you can see that the 1 of 2 initializes a new instance of the system.random class using a time-dependent default seed value. Now we can also give it a specific seed value. Like, for example, I could type in 1, 2, 3, 4, 5, 6. Now every time I ran the application, it will start with the seed of 1, 2, 3, 4, 5, 6, and it will be a predictable value every time we call the next method to generate a new random number. All right, so ideally, we're going to just let the application pull from the current system date time. Since our application runs in a fraction of a second, we're creating a new instance of random, passing in the same value each time. Again, the same time down to the second, and that accounts for the consistently generated value each time we call the next method immediately after creating this new instance of the random object. The reason why we got different values whenever we paused the running of the application and took our time and leisurely stepped through lines of code was because then the seed value essentially changes each time. There's a different value of seconds because we took a few seconds in between each run, so every time we create a new instance of the random class, we're giving it a different seed value. Okay, so to remedy this situation, ideally we'd only create a single instance of the random class. We create an instance of this class one time when we first run the application, then every other time we need it and call Random.Next, we can rely on it creating a simulated random value. So to actually accomplish this, what I'm going to do is comment out this line of code, and I'm going to copy that line of code and then put it right above our helper method, like so. Now at this point, the random class is only created one time whenever the application first starts up, whenever a new instance of the default class is created. Now again, I understand, haven't really talked about instantiation in classes and things of that nature yet, and constructors and stuff like that. However, essentially what I'm saying is every time the page is created, or whenever you make a request, a new instance of random is created one time, and then we can reference that single instance of random inside of the perform attack method. So perform attack is called many times. However, the random class is only seeded once, and each subsequent call to Random.Next will actually give us a random number, or at least what appears to be a random number. It's random enough for our purposes. So the key here is that random is only created one time, not every time the perform attack method is called. And since it's only created once, it's only seeded once, and therefore Random.Next will work as we intended it to. But now whenever we run the application, we should see random numbers generated. All right, so at first we start with the row of 14s and then 3s, and you know, there are some overlaps, but I look through the numbers and there's no discernible pattern. All right, so that is how you can correct the problem, and in the future, just make sure that you're only creating one instance of the random class, and then each time you call that instance, it will generate a new seemingly random number when you call the next method, okay? So hopefully that is an explanation for you that helps you understand how random works and that it's not so random, and then how to make it random again, or seem random, by removing the creation of the random class inside of our helper method. And each time our helper method gets called, we're not creating a new instance with the exact same seed value every time. We're only creating the new instance of the random class once, giving it a single seed value, and then letting the next method then use that seed to continue to generate random numbers. Okay, hopefully that helps. Thank you.